Hello students, welcome to IMS Gate Academy. In today's session, I would like to do certain number of gate questions. They were all selected from the 2021. Those gate questions also what questions? Only from the analog. I selected these questions only now. So the first question from the analog, branch EC, gate 2021. But anybody can try initially without my help this question. Any chance is there to give answer for this question? Any chance to give answer for this question without my help? But already in gate 2023 and 22, I have done problems on diode and also operational amplifier. So this diode problem you can tackle without my help. Anybody can do this problem without my help? Okay, will you please watch. An asymmetrical periodic pulse train V in, not V in, V in it is, V in of 10 volts amplitude with on time T on equal to 1 millisecond and off time 1 microseconds is applied to the circuit shown in the figure. The diode D1 is ideal. The difference between the maximum voltage and minimum voltage of the output waveform V0 in integer is dash volts. Is asking to find the output voltage. That output voltage he wants with a difference. What difference is a maximum output voltage minus minimum output voltage. The difference of that voltage only is asking to find. What I wish to say is asking to find V0 maximum minus V0 minimum. V0 minimum equal to how much is asking? Is asking to find that value. But what about this diode? Diode is ideal or non-ideal? The problem directly given, diode D1 is ideal. One point we know very well, when diode is ideal, what's going to happen? It can act as a short circuit if it is forward biased. If it is reverse bias, it can act as a open circuit directly now. So we can understand based upon the input voltage how the diode will be. When the diode is on, when the diode is off, you can understand based upon the given input voltage here now. There is a capacitor here now, and T on and T off given here now. The initially what I wish to say, what data is given here now? Given data, T on is given here, T on is given as a 1 millisecond. 1 millisecond is given. And also T off is given in the problem. T off equal to 1 microsecond it is given. 1 microsecond. But input voltage is given, what now? It is a periodic pulse train only given now. Periodic pulse train with voltage 10 volts only given. Amplitude is a 10 voltage it is given here now. Understand my point now. But anyhow, initially we can assume if Vn is greater than 0 voltage, how the diode will be? There is a forward bias or reverse bias we can identify. Then after we can find output voltage. My point is, output voltage of maximum I can get if Vn is greater than 0 voltage. That point very important now. If Vn is less than or equal to 0 voltage, V0 of minimum is possible from the given problem only now. Okay, initially I want to make an assumption. What assumption I want to make? If I am taking the solution here now. I made an assumption. If Vin is greater than 0 voltage, I have taken here now. Greater than 0 voltage, I have taken here now. If it is greater than 0 voltage, diode is forward biased or reverse biased. You check from the problem. the Vin is greater than 0 voltage, this diode is a forward bias. This is the P-type material. Here we got, this is P-type material. This is N-type material. P is connected to the positive potential only now. N is negative potential. 100% this diode is forward bias. So we can write here now, the diode is forward biased. I can put diode is forward bias only now. Diode is forward bias. If diode is forward bias, it can act as a short circuit. Diode is forward bias and replaced. And replaced, we can write directly. And replaced by short circuit, I can say. It is replaced by short circuit here now. If it is replaced by the short circuit, how the equivalent circuit is to be plotted? I will explain you now. In the problem, it is given the V in here. Yes, I will connect. I got here V in. I will connect here now V in. The periodic pulses is now V in. There is one capacitor. There is one capacitor. One resistor is connected here. There is one resistor. What its value? The resistance value 500 kilo ohms it is given. 500 kilo ohms. 500 kilo ohms it is given. What about this diode? This must be short circuited and open circuited now. Diode is on state. When diode is on state, it must be short circuited now. I want to short circuit the diode. This diode must be short circuited. Now we need to get output voltage across these two terminals. When you are giving the positive pulse, Vin is given the positive pulse, the output voltage, whatever you are getting, is said to be maximum voltage only now. This is V0 maximum, I can say here now. What voltage I can get? If it is short circuited, voltage across these two terminals is nothing but the 0 voltage only now. That 0 voltage is the maximum voltage only now. I say V0 maximum equal to V0 maximum equal to 0 voltage I can get. Yes, I am getting the maximum voltage. But you should understand one point. When diode is forward biased, what is the action of the capacitor? The capacitor will be charged. Slowly it is starting from 0 voltage to what? Maximum voltage only now. Maximum voltage how much? It's given 10 voltage. V in of maximum 10 voltage is given. Amplitude is given in the problem. You check it once again. The amplitude of the V in is 10 voltage is given. So here voltage what we can get is nothing but the maximum voltage only. Whatever the voltage we are getting across the capacitor will not have any effect on the what now? This output voltage. This output voltage, because it is short circuited directly 0 only now. The importance of this voltage you can find only when diode is a reverse bias only now. You will see now. You can understand it clearly now. In the next case, what I did, in the next case, if V in is less than or equal to 0 voltage, you can use. It is nothing but the periodic pulse. Periodic pulse means 100% maximum voltage at 10 is given in the problem. Minimum is a 0 voltage only possible. But I gave less than or equal to 0 voltage only. If it is less than or equal to 0 voltage, you check it, how the diode can behave. The diode will be reverse bias. Less than or equal to 0 means diode is a reverse bias. If diode is a reverse bias, it can be replaced by what? Open circuit only now. I can draw the diagram here now. It must be replaced by open circuit. I say there is voltage source here. There is a voltage source, that is a V in. There is one capacitor. There is one capacitor and one of the resistor is connected here. But this diode can act as a open circuit only now. Why diode is acting as a open circuit means because it is a reverse bias. Thus we can write one sentence here now, you can understand clearly now. Diode is, if V in is less than or equal to 0 voltage, diode is reverse bias. If diode is reverse bias, it must be replaced by open circuit. Directly you can write now. And replaced by open circuit, we can say. That is why the open circuit here made now. Whatever the output we are getting at less than or equal to 0 voltage must be taken as a V0 minimum only. This voltage must be taken as a V0 minimum. That voltage must be taken V0 minimum only. But I said already now, once the diode is forward biased, voltage across the diode will be 0 because it is an ideal, I said. But voltage across the capacitor is possible because charging of the capacitor is done because of the connected input voltage only. What voltage? Because when the positive pulse is given initially, this can get the positive polarity, this can get the negative polarity only now. Maximum amplitude when Vi is greater than 0 voltage means maximum voltage I can get across the capacitor is 10 voltage here now. That is said to be capacitive voltage only now. This voltage I am getting when Vi is greater than 0 voltage. That voltage will be there in between the what will be in between the two plates of the capacitor only here possible now. Understand now. Then what is going to happen? We want to find what is V0. What about that resistor? What is the value of resistor? 500K it is given here now. This is 500K. This is 500K I can put now. But I wish to find what is V0 minimum here. V0 minimum. How we can find the V0 minimum? V0 minimum is nothing but V in minus voltage across Vc only now. I can write V in minus the voltage across the capacitor. The rest of voltage is nothing but this node voltage. This minus this voltage equal to this node voltage. This node voltage is nothing but the V0 minimum only. V0 minimum only now. So what is V in? V in equal to, we can put, I am putting V in equal to 0 voltage only. The periodic pulses we can find the minimum voltage 0 voltage only now. 0 voltage I am putting here now. Then V0 minimum equal to V in is a 0, Vc is nothing but a 10 voltage. Finally we are getting minus 10 voltage here now. I can get minus 10 voltage here. Here I can get minus 10 voltage. V0 minimum is nothing but the minus 10 voltage. In the problem is asking to find V0 maximum minus V0 maximum minus V0 minimum. That difference is required. That is the question asked in the problem. V0 maximum we got as about 0 voltage minus V0 minimum is nothing but the minus 10 voltage. I can put this minus 10 here as it is. Finally, this voltage will be 10 voltage, I can say. Answer is 10 voltage. Difference of that voltage is nothing but 10 voltage we can get now. Understand now. This is the answer for this question now. So finally here the V0 in integer is at 10 voltage only possible. I can write that difference of the voltage is 10 voltage. This is 10 volts. This is the final answer. Anybody having any doubts regarding this problem? Yes, I will give you the next question. You please try to tackle this question without my help. This is the next problem. Any student can find this value, but I want to give some time. You please try and get answer for this question. Any student can do this question without my help? Without my help. Can you do? Just I want to wait for some time. You please complete this. You take time and give answer. What answer we can get? Okay, I will do here now. You also try. If you are getting answer immediately, you send it. For the transistor M1 in the circuit shown in the figure, transistor means MOSFET only now. MOSFET comes under the family of transistor only. Mu n COX is nothing but 100 microamperes per square volts given. And W by L equal to 10, where mu n is the mobility of electron given in the problem. COX is the oxide capacitance per unit area. W is the width and L is the length. Circuit is given. The channel length modulation coefficient is ignored. If the gate to source voltage VGS is 1 volt to keep the transistor at the edge of saturation, then the threshold voltage of the transistor is required. What is asking? Is asking to measure threshold voltage. Threshold voltage is required. But threshold voltage is required to keep the transistor at the edge of the saturation. To keep the this MOSFET at the edge of the saturation, what threshold voltage is required? That is a given problem. I will note down the data, you can understand clearly. But we can note down the data here now. Mu n COX is given. Yes, I will put once again here now. Mu n COX is 100 microamperes per square volts, it is given. W by L equal to 10. W by L can also be called as an aspect ratio. One more name. So we can write aspect ratio is given in the problem. Aspect ratio is nothing but W by L. It doesn't have any units. That is nothing but 10 it is given. This is given 10. Mu n equal to mobility given. COX means oxide capacitance is given in the problem. Channel length modulation coefficient is ignored. Channel length modulation is denoted by symbol lambda. Lambda equal to 0. Specified in the problem strictly. Directly we can put. And also given VGS equal to 1 voltage is given. Gate to source voltage. The gate to source voltage is given. VGS is given in the problem 1 voltage. VGS equal to 1 voltage is given. To keep the MOSFET at the edge of the saturation, what threshold voltage is required? Is asking to find. What threshold voltage is required to keep the transistor at the edge of the saturation? At the edge of the saturation means just it enters into the saturation region. What threshold voltage is required? At the edge means just entry only now. When we can say the MOSFET is in saturation mode, what condition if satisfied you will say MOSFET is in saturation mode? That point is very important. We can write MOSFET is in saturation mode. In saturation mode. When saturation mode? When we can say drain to source voltage is very important. Drain to source voltage must be greater than or equal to VGS minus VT must. VGS minus VT. Not only this condition, one more condition is there now. VGS must be greater than threshold voltage. Initially you must check VGS must be greater than VT. First condition. VGS is greater than VT means it is not sufficient. And also it must be, what is must be? VDS, drain to source voltage must be greater than or equal to VGS minus VT only now. One more point you have to remember. Greater than or equal to is given. VDS equal to VGS minus VT, you think it's so. Not greater. Equal to VGS minus VT if it is taken, then we can say the transistor is at the edge of the saturation only now. If it is at the edge of the saturation, drain to source voltage is equal to VGS minus VT only now. So we need to take greater than or equal to VGS minus VT or equal to the VGS minus VT means equal to VGS minus VT only. Because in the problem it is strictly specified, it is at the edge of the saturation only given. That's why we must take equal to only here now. And here VDS means what? This is the VD, drain voltage, I can say. This node voltage, the drain voltage. This is said to be source, VS, VS only. What is VDS? You watch. VS equal to how much possible below this line, below this point, whatever the voltage you are getting is VS only. Below this node, we are getting the zero voltage only. I can say VS equal to zero voltage only. It doesn't have any drop, any voltage source is not connected. Directly you can put VS equal to zero voltage only. But VD is not zero voltage. VD only V out. VD equal to what? Supply voltage minus some current is going to flow here now. That is the drain current. VDD minus ID into RD is nothing but VD value. The drain voltage is nothing but VDD minus ID into RD only now. That voltage is VD. Now the point what I wish to say is VDS is nothing but, clearly I can give now, VDS is nothing but VD minus VS. VD minus VS only now. VD minus VS means VS equal to 0. Here we got VS equal to 0. When VS is 0 means I can put only VD only now. VDS equal to VD only possible. Catching my point now. That's possible here now. But VDS equal to VD, that condition I want to apply here now. What is VDS? I said now VD equal to VDS equal to VD only I said now. What is VD first of all here now? VD is nothing but VD or VDS, no problem. VDS is nothing but VDS also, no problem. 3 voltage minus drop across this RD, ID into RD. ID into RD. ID is nothing but the drain current. Drain current we can take. But that is possible here now. VDS equal to 3 minus ID into RD only possible now. But this VDS must be greater than or equal to VGS minus VT. This value, VDS must be greater than or equal to VDS minus VT only now. But equal to I want to use. Why you are using equal to, sir? The reason I said already now. It is at the edge of the saturation only now. But a VGS is given in the problem. What is given? 1 voltage. VT we need to calculate. Threshold voltage is to be calculated. That value is required only here now. Without knowing the what RD means, it is given directly. Drain resistance is given 20 kilo ohm. Directly I can use that value. But drain current is not given. We know very well the drain current is calculated by what formula? There is a formula. 1 by 2 into mu n COX into W by L into VGS minus VT whole square when MOSFET is in saturation. You know very well now. So I want to use here now 3 minus ID. ID is nothing but the drain current is calculated by mu n COX divided by 2 into what? W by L VGS minus VT whole square. This is the drain current formula. This is multiplied by RD into RD. That equal to 1 minus VT. I can put directly. That equal to 1 minus VT. We can substitute the values directly. 3 minus mu n COX is given in the problem. Mu n COX is given 100 micro. 100 micro. Amperes per square volts. Divide by 2. W by L. Aspect ratio is given 10 in the problem. VGS is given in the problem. VGS is 1 voltage. We want to find threshold voltage. RD, drain resistance is given 20K into 20 kilo ohms. That equal to 1 minus VT. Yes, finally we are getting equation in terms of threshold voltage only. Expand the whole function. You are going to get one quadratic equation. By solving the quadratic equation, you can find what is the threshold voltage. Just I will give the quadratic equation, what you can get. By solving that, we can get answer. That quadratic equation you will get from this is, if you expand it, you will get the equation like that. Just I will give now. Yes, it comes like this. Vt square minus 21 Vt minus 21 Vt, Vt square, sorry, 10 Vt square, I'll just write this now, 10 Vt square only now, 10 Vt square minus 21 Vt plus 8 equal to 0. That equation you are going to get mostly now. 10 Vt square minus 21 Vt plus 8 equal to 0. Can you solve this? If you are solving the threshold voltage, you will get two values like this now. One is a 0.5 volts, and second one is 1.6 volts mostly possible. 1.6 volts possible now. These are the two values are possible. But we are getting the two values, but we must take one value only now. Two values are not acceptable now. Which value is to be taken? Very beginning of this problem, I explained VGS, the condition, one more condition, VGS must be greater than threshold voltage only. Strictly given that point only now. VGS is given 1 voltage only now. So that voltage must be greater than threshold voltage. So at the time, what VT is to be taken? 0.5 voltage only. VGS 1 is greater than 0.5. It is not greater than 1.6 voltage only now. At the time, 1.6 cannot be taken. We can take this value only now. If VGS is a less than VT, you think it's so, you know very well, MOSFET is in cutoff region only. It will not enter into the what? Saturation region. So it cannot be 1.6. Sir, I will take 1.6. Sir, yes, you take it. What happens now? It comes to off state only now. That MOSFET only now. But we want, it must be in saturation. That's why finally we can write now VT must be equal to, threshold voltage must be equal to 0.5 voltage. Because VGS is greater than what? Threshold voltage. From this point only now. This is the solution of this question. I think you followed better. Anybody having any doubts regarding this question? The solution I did. Anybody having any doubts? If there is any doubt, immediately you message. I am ready to clarify your doubt. Any student? Any student having any doubts? Yes, I will do the next question now. This is the next problem. But I want to give you some time. Initially, I wish to give time to do this problem. It is also GATE 2021 only now. GATE 2021 only now. This is also GATE 2021. 2021 question only now. Anybody can do this question? This is the question from the operational amplifier. Most on the GATE we can expect problems from the operational amplifier now. Anybody can do this? Sorry. Anybody can do? Anybody? Yes, I will explain that. Consider the circuit with an ideal op-amp shown in the figure. The circuit is given there. Assuming mod Vin is far more less than mod VCC and modulus of V reference is far more less than modulus of VCC. The condition at which V out equal to 0 is. 4 options are given. What is strictly specified in the problem? Two sources are connected here. One is a V in, one is a V reference. Two sources are connected. There is an operational amplifier. Is it an ideal or non-ideal? Strictly given, it is an ideal op-amp. It is given ideal op-amp only. It is an ideal. And also in the problem what is given, V in is far more less than V modulus of VCC plus VCC or minus VCC modulus only finally. As compared to this value, VCC, V in is a very, very small, he says. Even V reference also, modulus of V reference is far more less than modulus of VCC is given. We know very well, these two are nothing but what? Biasing, sources only. The op-amp can have internally transistors only now. They must be biased. That's why we are going to use plus VCC and minus VCC here now. Anyhow, the output voltage must be within the range of plus VCC and minus VCC only now. These are the biasing voltages will not allow more than plus VCC or less than minus VCC. The output voltage now be possible. Understand now? Because the maximum, this is the saturated voltage. Positively saturated transistor means plus VCC possible. Negatively saturated means minus VCC is possible. So, now anyhow, in the problem, what is asking to find? To get output voltage is equal to 0. That point very, very important. V out, I want to get 0 voltage. If I want to get the 0 voltage, which condition is going to satisfy? Which option is correct is asking now. It's a very simple question. Anybody can do easily now. Yes, I will explain. Please watch. This is ideal op-amp is given. In ideal op-amp, you know very well, V plus and V minus are same. You know very well. For ideal op-amp, ideal operational amplifier, V plus is equal to V minus only. That condition will be satisfied only now. So what is V plus? 0 voltage only now. We got only 0 voltage here I got. V minus also same 0 voltage is maintained. V plus and V minus are same. When op-amp is ideal, you know very well. If it is a 0 voltage, even this voltage also, we can say same 0 voltage only. Same 0 voltage only. We don't have any resistance in between these two. If you want, you can combine these 2 points. You can take it as a single node. There is a single node only. Don't take 2 nodes are there now because it doesn't have any resistance one. Then V out must be 0 voltage required. V out must be 0 voltage required. So you find the condition. It is better to apply nodal analysis. By using the nodal, very easily you can get answer. Nodal means from the node, these two are nothing but single node only. This current plus, this current plus, this current equal to 0 only. You should not say, sir, what about the current? These sides are negative electrode. It doesn't flow any current. The current passing through the what now? This negative terminal is a 0 amperes only. The reason you know very well. For ideal op-amp, input impedance of the operational amplifier is very high. That is infinite, they will take it now. Infinite resistance means current is approximately 0. You know. That's why this current and this current and this current equal to 0 as per nodal. And I can form the equation like this. 0, this current I want 0 minus V in, I can write directly 0 minus V in divide by resistor R plus as per the nodal plus this side what current is passing? Current across R. 0 minus of this minus. Here the minus is the minus of minus. 0 minus what voltage here now? Minus V reference divide by what? Divide by R. Divide by R. Plus still what? 0 minus output voltage 0. 0 minus 0, 0 by RF. 0 by RF. 0 by RF is a 0 only possible. Otherwise, I am a very perfect way 0 minus V out. Exactly means 0 minus V out. 0 minus V out. This voltage minus this voltage equal to RF. V out is a 0 voltage only. Now we can write clearly now. The condition I can get now. Addition of all these currents equal to 0 only possible. As per nodal analysis, I have written this equation. Finally, what I am getting here now? What I can get? This is a minus, 0 minus, minus of minus, this minus V reference. V reference with minus we got here now. 0 minus we got. Minus V reference. This is minus V in here. Minus V in divided by R. Minus minus plus V reference by R. I am getting here now. V out is 0 only now. This is finally 0. I am getting equal to 0. I can cancel R terms here and here. I can cancel the R. Finally, I am getting here now. V in equal to V reference only possible. V in equal to V reference I am getting now. This is the condition. What it says, if you want to get output voltage of 0, V naught equal to 0 voltage is required. This condition must be satisfied by the given network. So which option is correct here now? The 4 options are given. Out of these 4, we can select option D is the right answer. Option D is the right answer. V in equal to V reference only. Any students are having any doubt regarding this question? If you have any doubt, immediately you can message. I am ready to clarify your doubts. Anybody having any doubts? Yes, I will go to next question now. I want to go to next question now. Now you please try this question. It's a GATE 2021 analog question, but branch is EE. From electrical paper, this question was asked. Anybody can do? You take some time and give answer. You take your time and give answer. I will wait for some time. I want to wait for some time. You please try this question. You please tackle this question without my help. Yes, what is given in the problem? This is the question from the bipolar junction transistor, BJT only now. In the BJT circuit shown, beta of PNP transistor is 100. Beta is given. The gain, what gain? Current gain of the amplifier, this transistor is given 100. It is a PNP transistor here now. VEB, emitter to base means 0.7 only. Base to emitter means minus 0.7 only. Because it's a PNP means this side. This is emitter. This is the base. This is the collector. Emitter to base 0.7 voltage. Emitter to base. Base to emitter minus 0.7. Reverse means minus 0.7. In this direction 0.7. Now can you say, but this is 0.7, you know very well. This voltage is equal to how much? The voltage, and also in the assume VBE equal to 0.7, no doubt. The voltage across RC is given in the problem. The voltage across RC will be 5 voltage. The voltage across these two terminals is given 5 voltage only now. This is given 5 voltage. Voltage across this collector resistance is given 5 voltage. R2 is dash kilo ohms. Is asking to measure what is R2. That value is required. How to measure R2? I will give the concept clearly now. We know very well this node voltage is nothing but same 12 voltage. Same 12 voltage you can have here now. If you know this current is nothing but emitter current, you know very well. When this current comes, is a PNP, this current, this side current is to be taken base current here now. This current is taken base current. This is base current. The current which is passing this side is nothing but the collector current, I can say. That is the collector current one. From the given problem, you measure at first what is IE. Emitter current is required. How I can measure IEs are? IE, if you want to get, means IB and IC values are required. IB and IC values are required. How to get IC? IC is nothing but the current across this RC. Voltage across RC we know 5 volts. RC is nothing but the 3.3 kilo ohms. 5 by 3.3 K is nothing but IC. Directly you can measure IC value. Once you got IC value, IB is nothing. You know very well. IC equal to beta into IB. IB equal to IC by beta. Beta is given. IC you can get here now. IB you can calculate. IB you can calculate. And also what I wish to say, this current is IB. This current I would like to denote I1. I want to denote. The current which is passing through this R2, I wish to take it as a I2. This current is I2 only. Without knowing I2 value, I cannot determine R2 value. I2 required, and also this node voltage is also very important. So resistance equal to voltage by current. If I know this node voltage Vx, this voltage, Vx by I2 is nothing but what? R2 value only now. Voltage by current. Voltage by current we get. But how to get these values? One by one I will determine. Easily you can understand. Initially I wish to find what parameter here now? IC I can determine directly. The collector current is nothing but voltage across RC, 5 by RC only now. VC by RC, 5 by RC is nothing but 3.3 K. This is IC. Anybody can say what IC you can get? Use calculator and give me. Anybody? Anybody can give what IC you can get? What IC you are getting? Anybody? 1.515 it comes. 1.515 milliamperes of current is possible. Milli because divided by K only now. I said IC if you got means don't satisfy. IB also must. IB also must here now. How do you get IB? IB equal to, you know, formula. IC by beta. IC by beta I can write. We got IC here 1.515 milli 10 power minus 3. Beta is given in the problem. PNP beta is given as 100 here now. Yes, I will put 100 here now. That is IB. But finally that IB comes as 0.01, 0.015, 1515. 0.1515 milliamperes it comes. That much milliamperes of current is possible. 0.01515 milliamperes possible. Sorry, milli means it comes 1.530. Yes, that much possible. Yes, that much IB is possible now. That is the base current. But why we are calculating this IB and IC means to measure IE. That is our main aim. IE equal to we know very well. IB plus IC. IB plus IC. Otherwise, I will use 1 plus beta into IE equal to 1 plus beta times of IB. That also accepted now. You can use any one other formula. But in that case, you are going to get 1 point IB and IC. IB you know, IC you know. It comes as 1.530 5303 milliamperes of 03 milliamperes of current is possible. 5303, that much current is possible now. This is IC. Yes, now we can see. Sir, what is the use of finding these IE and IB and ICs are? Because if you know the Vx and I2 value, then only you can determine R2 value. To measure that Vx, I wish to find this node voltage. This node voltage I can denote by symbol VE. When these are some voltage we can put now. Emitter voltage VE we can put best. This is the VE value at this value. I have taken this node voltage VE value for example. Now requirement some Vx or Vy or Vz or something. This voltage is nothing but the 12 minus drop across this RE. 12 minus drop across RE is nothing but VE only now. I say this VE is nothing but emitter voltage is nothing but 12 minus 1.2k into 1.2k into 1.2k into IE. IE is nothing but this 1.5303 milliamperes of current is possible. On simplification, you will get VE as 10.1636 volts possible. That much voltage is possible here now. That much voltage is possible. That much voltage only possible. Follow this now. Sir, why we calculated this VE? One more. We calculated VE. Why this VE requires? To find this Vx. VE minus 0.7 is nothing but the Vx only. VE minus 0.7 equal to Vx only. That's why I want to find, to measure this Vx, I calculated VE. The Vx is nothing but VE minus 0.7. Minus 0.7 I can write. Minus 0.7. What VE you are getting? 10.1636 minus 0.7. Finally, Vx is, it comes as 9.4636 volts. 9.4636 voltage. I am getting the Vx value. I got voltage, but I want this I2 also. Without I2, I can't do anything. How I can get I2? IB plus I1 equal to I2 only. This I2 is nothing but this side IB, this side is nothing but I1. Addition of these two currents equal to I2 only now. So without knowing I1, I can't get I2 again. Because I1 is nothing but the current across 4.7 kilo ohms. How I can get? Ohm's law. 12 minus Vx by 4.7k. Directly I can get. I say I1 is nothing but 12 minus this voltage minus Vx is nothing but 9.4636 possible. Divide by resistor. What resistor? 4.7k. 4.7k. Use calculator. If you are using the calculator, you will get as a 0.5396 milliamperes of current is possible. That much current is possible. That is I1. This is I1 I am getting. Now I want I2. I said already I2 is nothing but this current plus this current. I1 plus IB only now. I1 plus IB I can write now. I1 plus IB I can write here now. I1 plus IB. I1 plus IB means I1 we know very well. What is I1? I1 0.5396. IB is nothing but 0.01515 milliamperes now. Finally, I2 will be, I am giving directly I2 value. That I2 will be 0.55475. That much milliamperes of current is passing only now. We got I2, then it is simple. The problem is somewhat lengthy only now. Understand now. Sometimes you can expect such type of lengthy questions also. R2 I want. R2 equal to Vx by I2 only now. Ohm's law I applied. Vx by I2. Vx by I2 I can write now. Vx is nothing but we got already 9.46, 9.4636. Divide, there is a Vx value, by I2. I2 is nothing but 0.55475 milli 10 power minus 3. The finally R2 will be, R2 equal to, it comes as 17.05, 17.0592 kilo ohms possible, 17.0592 kilo ohms possible. Such a way the question is to be done only now. So finally R2 we are getting in kilo ohms. That is the final answer only. I think you followed. If any student having any doubts, they can arise their doubts. I am ready to clarify. If any student having any doubt, please arise. I am ready to clarify their doubts. Any doubts, anybody? So these are all the problems from the what now? 2021 certain questions I selected. I did only now. Tomorrow also you try to attend 2020 questions I will do from the analog standard. 2020 questions you can expect tomorrow standard. I hope you followed so far. Thank you.